Hello everyone and welcome to my first video on my journey to teaching math conceptually. My name is Mr. Everett. My students call me Mr. E, and I've been teaching middle school math for over 10 years. But this year, in August 2021, I'll be making a big shift. I'll be making a big shift to teaching math conceptually. But enough about me. Let's get to what you're here for, and that is to discuss what is concept-based math. What is concept-based math instruction? So my agenda is, what is the shift? And I'll answer that question by looking through the lens of a comparison between inductive and deductive teaching methods. And then we'll talk about the ideas of uncover and transfer. So what's the shift? What's inductive? What's deductive? Well, I'll compare these two using what's called a thinking map. What are thinking maps? Well, thinking maps are consistent visual patterns linked to 8 specific thought processes. The process I'm going to focus on today for comparison is a double bubble map. How does that work? We'll have my two concepts here, inductive, deductive. In the middle, what they have in common, and the left side and right side, what's different about them. All right, so inductive versus deductive. Well, they're both very valid methods of teaching. In the deductive approach, it's teacher-centered, whereas the inductive approach is more student-centered. In the deductive approach, we generally tell the student the generalization, whereas in the inductive approach, we act more as a guide to help the student come to their own understanding of the generalization through inquiry. The deductive approach is considered to be a traditional approach, whereas inductive is more of a concept-based curriculum approach. Okay, let's go through a few examples using Pythagorean theorem to get a little more specific. So notice, first of all, the objective in the deductive approach talks about what the student would do. And if you notice, a lot of your standards, or most of your standards, are written as what the student will know or what the student will do. So an example, teacher may give generalization in the beginning of the lesson. A squared plus b squared is c squared. Go through a few of examples, some Pythagorean triples, work them out, work with the student, let the student work in groups or work individually, maybe assign a few homework problems. I want to talk a minute specifically about student questions, studying specific examples. I taught in Texas for many years, where our state test was called the STAR test. So we would go over a lot of the STAR release questions, break them down in certain subsets, find the side, application, different types of questions that appear on the test in previous years. The idea being, if they know how to do these questions, then they must understand the concept of Pythagorean theorem. Now let's compare that to inductive. Notice already a difference in the objective. The student will understand the relationship that exists between the side lengths of a right triangle. Again, teacher as the guide. So one example could be, let's give the students a student-centered example where they have to match the squares of the sides of a right triangle, or match the squares with the sides of a right triangle. And we begin to give them inquiry questions, notice anything about the relationship, so on and so forth. Again, we're guiding the students to the generalization. We continue with our inquiry. Any connections? Is this true for all triangles? Eventually, through inquiry, the students will come to the generalization on their own. So what is this shift? And what is concept-based teaching methods? Well, concept-based methods are based on inquiry, whereas procedural-based methods are not. Our shift is we want to go from a procedural-based math approach to a more concept-based math. Now, see, I said more there. There is a place for procedures and teaching procedures, but we want to focus and be more intentional about teaching through inquiry and a concept-based approach. And finally, the ideas of uncover and transfer. When we uncover or help the students uncover these generalizations, we're guiding them to use their prior knowledge to construct their own understanding, their own generalizations. And then once they understand those generalizations, they can then transfer them. So again, like the previous example, Pythagorean theorem. One thing to keep in mind, we do not see students as empty vessels who come to be poured into. We have to recognize they have prior knowledge that we have to build on. Again, we're going to give them a student-centered example, and they're going to come to the generalization. And once the students have the generalization, they can begin to ask and answer the question, where else can I use these right triangles? For example, they can use them in art, architecture, or they may be able to help their parents find the hypotenuse on that garden in the backyard that's in the shape of a right triangle. The idea here is that if they understand, then they will know what to do and why. All right, so let's summarize this. The comparison of inductive and deductive approaches to teaching. One way to summarize it is conceptual understanding is if they understand, then they will know what to do and why. Deductive or procedural approach is if they know how to do it, then they must understand it. And finally, concept-based math or teaching math conceptually is an inductive inquiry approach where the teacher is the guide. The teacher is going to look into the student's prior knowledge or use that to guide the student to construct their own understanding, uncover. And once they uncover, the student will be able to transfer that knowledge to different areas, whether it be inside math or outside. All right, thank you for watching video number 1. Hope to see you in video number 2. And remember, teachers, keep guiding those students to conceptual understanding. Talk to you soon.